Chapter 7b on solving x's on both sides. In this chapter, you'll learn to solve for x when it's on both sides of the equation. Now, the prerequisite in this chapter is to make sure that you understand what it means to combine like terms. So if you have a 2x plus an x plus a y plus a 3y, we know that these are like terms, so we combine them to make 3x's, and we know that these are like terms, so they combine to make 4y. Or if you have 2x's plus 4 plus y plus 3y plus 5, we know that the 4 and the 5 are like terms, so that makes 9, a positive 9, and that the y and the 3y together make a positive 4y. And well, the 2x is no friends, and it's going to be by itself, and so it makes an expression that looks like this. So this is combining like terms. If you don't remember this concept, it's important that you talk to your teacher or you revisit a tutorial about combining like terms. So here we go. In the last video, we talked about using an inverse method or using an opposite method or doing these mentally. In this case, you want to make sure that you actually start using a written method because, again, it's only going to become more difficult. So in example A, I will use the opposite method. And what I'm going to do is, first of all, I notice that there's a 7x, a positive 3, a 4x, and a positive 18. I need to make sure I put the x's that are on opposite sides together onto one side and the numbers onto the other. So I would like to move that 4x over to the 7x, which makes it a negative 4x. And I would like to move that positive 3 over to the other side, making it a negative 3. So I'm going to go ahead and rewrite this on both sides of the equal sign so I clearly see it. That's 7x minus 14x. And it doesn't matter if you write minus 4x plus 7x, as long as you keep true that that 4x is a negative. Then on the other side, I write 18 minus 3. Or you can write minus 3 plus 18. It's the same thing. Now 7x's minus 4x's will equal 3x's, and 18 minus 3 will simply make 15. Now from here you can solve. 3x equals 15. 3 times what makes 15? X is equal to 5. Okay, so that's one way you could end up using opposites. If you use the inverse method, simply you choose to say, okay, I'm going to go ahead and subtract the 4x from both sides, and that will then make 3x's plus 3 is equal to 18. I'll minus the 3 from both sides, which makes 3x's equals 15, and then I divide both sides by 3, which makes x equals 5. So that's using the inverse method. Now, the question I commonly get asked is, well, what if I move the 7 over here and I move the 18 over there? Does it change anything? Let me demonstrate. So if I do that, this becomes negative 7x, and this becomes negative 18. So if I draw that line to divide both sides, this becomes negative 18 plus 3. Keep the 18 negative because it moves, so it's opposite. And the 4x minus the 7x. So when you do that, you have to be really good with your integers. Minus 18 plus 3 is minus 15. 4x minus 7x is minus 3x. So if you notice this line, it's actually just the same as the last time, but they're now negatives. So you have to be comfortable with saying, oh, it's negative 3 times what makes negative 15. In this case, x has to be a positive 5 because negative 3 times 5 makes negative 15. So the answer is the same. So it doesn't matter what you move where. It's just depending on your comfort of working with negative numbers and positive numbers. So at this time, pause and try to do B and C on your own. Okay, so let's go ahead and let's play with this. In B, I'm going to go ahead and use my opposite approach and move what I need to move. So I'm going to take the 4x and make it a negative 4x on the other side. I will move the positive 2 and move it to the positive 9. So that makes it a negative 2. So if I draw my line down the equal sign, I will know that this becomes 6x minus 4x, which makes 2x's. And the other side is 9 minus 2, which makes 7. So then finally, I have to divide 2 times what makes 7. Well, clearly it's not a whole number. It will have to be a decimal. So actually, I do need to do some division. So I know that x is going to be whatever 7 is divided by 2. And in this case, 7 divided by 2 will be 3.5. In the last problem, I'm going to choose to move my 4x over to the 8x, and I'll move my 16 over to the 8. So that means this becomes negative 4x on this side, and that becomes negative 16 on that side. So if I draw my line down the page, I'll rewrite everything as 8 minus 16 is equal to 8x minus 4x. In this case, 8x minus 4x makes 4x's. And 8 minus 16 will make negative 8. And so, now I have to ask myself 4 times what makes negative 8? I know that x has to be a type of 2, but since it's a negative 8, I know it has to be a negative 2. And that's all.